Hey guys, Mrs. Dan's here. So today we are on lesson 6. We will still be using the Pythagorean theorem, but we will be using it to find the lengths of line segments on the coordinate plane. So we will be plotting points, drawing right triangles, using the Pythagorean theorem so that we could find how long a side is. So if you could just write down the objective, do the do now on page 21. And also, I have posted your homework answers. So check that, and then I'll go over the do now and the lesson with you. So we can use the Pythagorean theorem to determine if these three numbers actually work in the Pythagorean theorem to make a right triangle. Remember that the hypotenuse has to be the longest side, which is side C. So out of these three numbers, 35 would have to be C. The A and the B don't really matter, but I'll just do it in order. So 21 squared is 441. 28 squared is 784. And 35 squared is 1,225. So when I add these, I get 1,230, which does not equal 1,225. So these sides do not make a right triangle. So when we want to know how long a side is on a piece of graph paper, I can't count if the line is diagonal, like this line AB. It's not a number of boxes I can count since it kind of goes slantwise through the boxes. I can count the horizontal and vertical sides though, so I can draw a right triangle out of this line AB, and I can then use the Pythagorean theorem. So if I were to count this bottom side, I would count it to be 1, 2, 3, 4, 5, 6, 7, 8 units long. And if I were to count this vertical side, it's 1, 2, 3, 4, 5, 6 units long. And that would be our A and B. This would actually be side C. So I could say that 6 squared plus 8 squared should equal C squared. So C squared equals 100. When I square root both sides, I get that C is 10. So the length of side AB is actually 10 units. I'm actually going to take away that box and put it over here. All right, side AB is 10 units long. And that's how we use the Pythagorean theorem on a coordinate plane. You just have to draw a right triangle out of the diagonal side. So let's plot point A, which is at 3, 2. So remember, before you plot, you should take a good look at your coordinate plane. Here's the x-axis, here's the y-axis, which means this is 0. So the point 3, 2 is here, call it A. 9, 6, call it B. If I'm going too fast, make sure you hit pause. I connect them and I can see it's a diagonal line. So now we have to draw a right triangle. Now there are two ways we could draw a right triangle. Just take a look for a second. I could draw a right triangle here, or I could draw a right triangle here. It really doesn't matter because the lengths of the sides will be the same, right? So I don't care if you draw the triangle below the diagonal line, above the diagonal line. I'll use what I did in red, and I'll count how long the sides are. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4. This is labeled C. So 4 squared plus 6 squared equals C squared. 16 plus 36 equals C squared. Sixteen and 36 is 52. I have to square root both sides. So C is about, right, it says round to the nearest tenth. Use that calculator. The square root of 52 is 7.211102551. If I round to the nearest tenth, it's a 7.2. Exercise 3. The diagram of the right triangle you drew in exercise 2 is shown below without the grid. How could the horizontal and vertical leg lengths be found using the coordinates from the endpoints? So here's what they're asking us to do. So this side is 6 units long. It was easy when it was on the graph. I could easily count 6 boxes. But what if we didn't have the coordinate plane and I knew what point A was, I knew what point B was, and I wanted to know how long this side was? Take a look at these numbers. So this is a 3 in the X spot. This is a 9 in the X spot. Do you see that if I do 9 minus 3, I get 6, right? And the reason why I use the X numbers is because this is horizontal. This goes like along the X axis. When I want to find this 4, now look at the Y numbers. Look at this Y and look at that Y. Isn't 6 minus 2 equal to 4? So if you know what the coordinates are, you can find the lengths of the horizontal and vertical sides by subtracting. So subtract the X values to find the horizontal leg, and then subtract the Y values to find the vertical leg. I have to tell you, on your test, I promise to always give you a piece of graph paper. Like, even if it's not part of the problem, you'll have a scrap piece of graph paper. I actually prefer graphing it and counting it. I don't prefer just doing the subtraction. I'm a very visual learner, so I'd like to plot it and see it. So we will be plotting them. I just wanted to show you that we could do it without graph paper. So we take a look at these points. For 3, we'll plot it right here, and it's point E. And then 9, 15. You're going to have to just like count the boxes on your own. First of all, these numbers look a little small for me. I can't even see them. I had to count. And copying me plotting points from the smartboard and you putting it on your paper, that's going to be practically impossible. So look at these points, plot it and call it point E and point F. Then connect them and you can see it's a diagonal line. When we have a diagonal line, you turn it into a right triangle. So draw a straight down line from F, draw a line straight out from E, and we have a triangle. Count the boxes. This is 5, and the other boxes, this is 12. Could have I just subtracted 15 and 3 to get 12? Yes. And subtract 9 and 4 to get 5? Yes. But I like putting it on the grid. Now I remember this is actually Pythagorean triple. This side's going to have to turn out to be 13. But let's prove it using the Pythagorean theorem. A squared plus b squared equals c squared. I really didn't know this 13 at first, so I'll label that side C, and we'll do 5 squared plus 12 squared, which is 25 plus 144, and 25 plus 144 is 169. And then we square root both sides, and guess what the square root of 169 is? It is 13. So if you do remember some of your Pythagorean triples, you can find the answer quicker. But the distance between point E and F is 13. Let's move on to number 5. Messier is laying out a garden in the shape of a right triangle. He draws it on the coordinate grid. The 3 vertices of his garden are at these points. So let's plot them. -3, -4 is here. We'll call it A. Then 6, -4, call it B. And then 6, 8, and call it C. Nicely enough, it is a right triangle. He wants to enclose the garden with a fence that runs along its perimeter. Remember, perimeter means add up all the sides. So a triangle has 3 sides. I need to add all 3 sides. So I can count side AB. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9 units long. I can count side BC. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's 12 units long. So to find perimeter, I have to add 3 sides. Unfortunately, I can't count this side, so I have to use the Pythagorean theorem. So this is a multi-step problem. First, use the Pythagorean theorem to find side C. Once I know side C, then I can add all 3 sides together. So Pythagorean theorem first. 9 squared plus 12 squared equals c squared. 81 plus 144 is 225. Square root both sides. C is 15. I'm just going to double check my math since I did all that in my head. So 81 plus 144 is 225, and the square root of 225 is 15. It is a Pythagorean triple. It's a multiple of a 3, 4, 5. So this side is 15. Now I can find the perimeter. The perimeter will be 15 plus 12 plus 9. 15 plus 12 plus 9 is 36. It's 36 units, I guess. Oh, how many feet? Okay, it's 36 feet. I guess each unit on this grid was a foot. All right, some practice. So why don't you try these two, and then you can check your answers with me. So letter A, you could see I plotted my points. I counted that the legs would be 8 and 15. I used the Pythagorean theorem and found that the diagonal side would have to be 17. And on letter B, after plotting the points and drawing a right triangle, I see my legs are 9 and 12. I use the Pythagorean theorem to find that the diagonal side, side C, would be 15. I just want to remind you that we could find missing sides sometimes quicker by recognizing if it's a multiple of a 3, 4, 5. This is a multiple of a 3, 4, 5. This would be the 3, this would be the 4, and this would be the 5, and they're all being multiplied by 3. Right? If I multiply by this side by 3, I get a 9. If I multiply this side by 3, I get a 12. And if I multiply this side by 3, I get a 15. So multiples of 3, 4, 5 sometimes are easy to recognize, and you can find your answers a bit quicker. But that's it for today. Today's homework is the same thing. Use these notes as model problems to help you through your homework. And I'll see you soon. Thanks. Bye.